Hello, everybody. Can you hear me? Yes?
Yes, we can hear you.
Awesome. We're going to wait a couple of minutes because I think we still have at least like two to three more people connecting. So we will start with uh, today's session. I apologize if I reply some emails like today in the morning Boston time, because I spent most of the time after the first session, then with work meetings, and then just like fixing my computer. So finally, I have the proper setup for the workshop. Uh, and also, I don't know if you saw the email, I uploaded um, the video on my YouTube channel, so you can check it. I didn't edit anything, so I will probably maybe in a couple of days just delete that one and upload a edited version that is shorter, that goes to basically uh, cuts the unnecessary things, because it's almost 2 hours. And I will do the same with this. So sometimes if I make a pause and I don't say anything, probably will be because those indicate a specific time where I will cut the video, and so it's more efficient. No one wants to do later or check a 2-hour video of someone speaking stuff. So for example, like this. Thanks. Okay, I think we're good to go.
Can I have a request,
Yeah,
Diego?
yeah.
So, would you please, like, before getting into the hands-on, tutorials, like before any of those projects, is it possible for you to first show us what we are eventually going to make, and then when we have a kind of like an image of what's going on, then we jump into coding and implementing? Like, for example, this sample that we started yesterday, it would be great if you could see what would be the final results, and then jump into implementation and writing the codes and other stuff.
Yeah, I will do that.
Thank you very much. Appreciate it.
Yeah. I mean, it's part of the uh, plan, because yesterday, yeah, it was like really introductory and I was facing some technical problems. But today I will show you like briefly what are we doing. I will show you in the first part this simple example, and then we will make it more complex. And I will again, these are super simple exercises, so tomorrow we can do something more complex and start making more advanced things. So let me share my screen so we can begin. I'll share just like a very brief presentation. Can you see the presentation screen? Yes?
Yes. Yep,
Yes.
we can see it.
Awesome. So basically what we did yesterday, right? We set up this scene with just a simple
Diego, sorry, we cannot hear you.
you cannot hear me?
Now we can hear you. Yes, we can do it now.
Probably also, let me see, because I think someone has the okay, I mute one person that had the mic open. Can you hear me now? Yes?
We can hear you now.
Yeah.
Yes.
Okay,
Clear.
good. So basically what we did yesterday was this, just like a simple environment where we have basically an agent, we have a target, we want this agent to learn how to reach this target. Something like really simple, it goes along with the example that I showed you yesterday on the child learning to walk, and it will be like pretty similar. So we have this block that represents the environment, basically like the surface. And basically just this will work like the following way. I will explain this. Basically, we have this learning environment, and then we will communicate with a low-level Python API that communicates or that basically uses this Python trainer. This is something that someone asked me, do you have documentation? I never used it because if I need to use like direct Python to do something, I just do it through, I use, for example, PyBullet or PyDrake, and I apply other algorithms there. So I haven't checked this Python package if you can do like things outside. So, but I will check and maybe we can comment something about it in the following session. And as you can see, basically, this means that the way you work is that all the complexity of your routines, all the interactions will start like, you can make them as complex as you want, right? And basically this part here will remain the same because basically Unity and ML agents are giving you basically everything so you can focus on setting up your scene and coding your behaviors and coding the way that your agents interact, and don't touch the Python part that comes with the ML agents package. So that means that you can have like many agents, you can set like your environment parameters, you can have like different behaviors, same behaviors for that agents that share, for example, like some behaviors or not. So basically you have like a whole range of possibilities, and it depends on how complex you want to make your stuff. I won't go into like more specifics, but I will focus on what we're doing now. And basically we will make this cube, as I was saying, reach the blue one, the target. And it can, basically what we did yesterday, we constrain the movement in the x-axis of this cube, so it can move only to the right or to the left, right? These are the two possible movements. And what we are going to specify is something like this, that when the cube, for example, is moving away from the blue cube, it will get a punishment reward, a negative reward. If it gets closer, it will get certain amount of reward. So basically it will become happier. And when it touches the cube, basically it will get like a big reward, right? Why this, for example, is because, for example, if you don't have this type of incentive, at the end, when you reach, for example, a target or you reach your goal, remember that this is a goal-oriented model, sometimes you can basically have the agent just like getting closer and being happy with the amount of reward that it's getting, but never basically getting the final push to touch the target. So it's always good to add like a little tricks. This is not very obvious, but basically it's a good thing that it can work like that. So we will go through the coding part, and we will see that we will have a pretty similar structure to every script that we make. We will have our imports. We will have, of course, like the global parameters and variables that we will use. We will have the initial settings that we have when we run a code. We will have also something that is called the episode begin. Basically, each time that we run an episode, and I will explain what an episode is when we actually code this, you will reset some parameters. For example, like the location of the cube, or you will change the position of the target. So you don't always have the target in the same position. Also, we have observations. We have a function that is like a typical one, where we basically collect observations. What are we observing that can basically give some clues to the agent so it knows how to move? And also we have a function that will take the actions, right? And also we'll have an update function to perform things that needs to be performed continuously. So we will have something pretty much like this. at the end of our first training. This will be in the first block, where you can see that each time that the block changes position, in this case, I have it inverted the colors, but the blue, the light blue cube is trying to touch the red cube, right? Is that clear? Yeah. This is the most basic example that I can show you on how to program an ML agent, but this will be the foundation for the more complex ones that we will do after this. So basically, this will be our template for the things that are coming after. So enough of that. I will close this. And I will open Unity. Some of you, I know, that had problems also installing, for example, ML agents or Unity versions. Mostly check if you are not done yet with that, if you have an antivirus, for example, blocking some stuff, or like a firewall, because I know that in the case of one person, she had Bitdefender, and Bitdefender was causing that Unity was not installing properly, especially Barracuda, because probably it's doing something with sockets and it's detecting probably that it's a malware or it's trying to do something on the back. So you need to check that, disable it, or hopefully, I don't know, like, or uninstall it. And also for people that had bad luck working with installing ML agents through PIP, through pip. I had the same problem last night when I was reinstalling everything on my computer, and it was because my connection was failing. So also check that. If you don't have a stable connection, probably it will yell at you that some error is happening. Okay, so first things first, this is exactly the same file that we prepared yesterday. We have the camera that is watching this. I will change the color so you can see it in a better way. We have our agent and we have our cube. And the way I have this set up, we will have a folder with materials that we did yesterday. By default, you have a folder with scenes that, remember, you can have like many simulations in one project. And we have something that is that basically is our script folder. But also we will add a new one. Just let me delete this. We will add another folder that we will use later that we will call models, where we will save the result, the weights that we get from our training. So in order to start this, remember that I told you, I don't know if we did it in the end of the tutorial, we had one scenario. We had the floor, the environment, we have the agent, and we have the target. And what we also want to add is here in a scenario, an empty game object. If you right click and choose create empty, we will make one empty game object that will be in charge of calculating everything for us. Basically, it will contain that script that will manage observations, movements. So basically, it's like the controller of our scene, right? And we will call this ML agent. You can name it whatever you want. That's fine. And as you can see, it doesn't have anything. To this ML agent, we will add, if we select this, we can go here to add component in the inspector. And we can add, as you can see, if you write something, we can say that this is, let's call it C agent or cube agent. If we write cube agent, here it will give us the possibility of adding a script, give it a name that is called cube agent. Actually, I will name it with C uppercase and A uppercase. And when you click on create and add, this will add this C# script to this game object, right? We are adding this component. If you want to do it in another way, what you can do is just right click here in assets, create C# script, and remember to name it before you click again, and then you're okay. And we will move this to the script folder. So once we have this, what we can do, we can double click in Cube Agent, and this will open Visual Studio Microsoft Visual Studio that looks like this. Can you see Visual Studio?
Yeah, we see it. Yep.
Good. One thing that is important. So here, something is happening. Here in my screen, if you see miscellaneous files, when you open Visual Studio, it's because you're not, basically there is something else that you need to do to configure your environment. Here, you should see the name of the solution, the project of Visual Studio. In my case, this is not pointing directly to that. So I need to close Visual Studio. And I will show you one more thing, because this is not basically, we will not have autocomplete, and it will give us error on some things. So I will close it. I will go to Preferences, Edit, Preferences. And when it says External Tools, make sure you have Visual Studio Community and Regenerate Project Files. If you have all of this selected, regenerate project files, and you should be okay, right? If you have, for example, open file by extension, probably you will get that miscellaneous thing. So if you have that, you're okay. We are good to go. We can open this, and hopefully it will. Yeah, now it's asking me for access, and we are good to go. So you see that it doesn't say now. It doesn't give me the miscellaneous, and now we have the option also to build, to compile our code. So as I was also explaining yesterday, the structure, basically you have the basic imports to have access to the different APIs and libraries that we're going to use. And in this case, we have system collections in case we want to use some system functionality, for example, time or things like that. Let me do one thing before I continue. Okay, so and also we have here that is telling us that this is a class Cube Agent, and this is inheriting from mono behavior. So we also have that possibility of basically will be recognized as a Unity script. If we don't have the mono behavior, basically Unity will not allow us to use this in some cases. But that's okay. So first thing first, we need to.
Sorry, Diego.
Yeah.
Sorry, I had some problems with my Visual Studio file. I have done all the things that you did with the miscellaneous files, but it continues to give me that error.
Did you press on the regenerate?
Yeah.
And did you close Visual Studio?
Yeah. I
Well,
close with Visual Studio, edit, preferences, and regenerate.
did you
Yes.
select the options, the checkboxes?
Yeah.
Okay, it doesn't matter for now. Probably the next time that you open Unity, it will be okay. I mean, if you get like some error, for example, or something is not like, if you don't get the autocomplete options, probably it will be a little bit annoying. But if you type everything okay, it will work anyway. So don't worry for now.
Okay.
So,
sorry.
No, that's fine. That's fine. If you have any questions, please just like let me know. The first thing that we're going to do, we need to make a reference to the objects that we have in our scene, right? So basically, we need to tell this controller, because this will be like pulling the strings of everything that's going on. We need to tell it who is the agent, which one is the target, for example, and some other parameters. So the first thing is that we will add the public object references. And basically, this will be exposed into Unity. So we can see this in Unity. So the first thing we will write, this is a public game object. And we will do the C, I'm going to call it C agent for the cube agent, right? We will add also a public game object target. And let's see what happens with this for the ones who have never worked with Unity. If we go to build solution, or if we do Control-Shift-B, right? Or Control-B or Command-B on Mac, this will start compiling. It will build your solution. And if you don't get any error, basically you're good to go. Now this is taking a little bit of time. So basically here it says that it built like everything is okay. We don't have any error, nothing failed, we're good to go. So what happens now is, because we have this correspondent or the process are connected, we see that now our script has two variables exposed into Unity, right? You should have this. Now you should have like one slot that is for the cube agent, the C agent, and other one that is for the target. And basically now this is pointing that we don't have anything. It asks you for a game object, but right now we don't have this game object. So the way you assign this, you can drag from your elements, from the elements on your scene. For example, I'm dragging the target here. This is one way that you can do it. And the other way is just pressing in this circle, and you can see all the objects that you have in your scene. And in this case, I will select the agent, right? If you have, again, any question, just let me know. This is like very simple. This is just like making the reference to this element so we can work with them. And if you remember, yesterday we, let me delete that. We added a rigid body to our agent. So basically it can have like some physics characteristics, and also can detect, for example, collisions. One thing that I told you that actually you need to, basically this is the configuration. We will use gravity. We don't want to tell it that it's kinematic. I can explain it later, but deselect this. So one thing that we want to do is go back to our script, and we want to make a reference to that component. So basically we need to read things that are inside that rigid body, because we will basically detect, for example, collisions. And we will, no, we will do that later. We will do one thing. We will add first a parameter. And we will add a public flow that will be called speed. Sorry, it's only speed. And we will give it like a 3. Because you will see, sorry, this is a public float named speed that we will use to basically give the movement. I can specify this later, but it's good that we basically do it now. So let's start basically by setting our initial functions, as I was saying. The first thing that we need to do is to set what happens at the beginning of an episode, right? So we will do what we can do is a public override. We are overriding this function, void. We'll call it on episode begin. And for some reason oh, sorry, I forgot to do one thing. Okay, it's good that this happened. I was going too fast. So you see that if I use this on episode begin, one thing is going on. It's giving me an error, right? It says that there are not suitable methods to override. It's because I forgot to do the imports. I was like jumping to the next step before doing that. So we need to actually tell our script to get the ML agents methods. So in order to do that, we have the engine, sorry, and another line we said like using Unity that ML agents. So ML agents to use ML agents in our script, in our code. And also we need to add another functionality of ML agents, that is unity.ml agents that, if I remember correctly, yes, sensors. So these are things that are new. So if you see me that I'm not very sure about what's going on, it's because I get confused with previous versions. In previous versions, you had to import this in a different way. And also what we are missing is to say that we don't want this agent to inherit everything from mono behavior, but we want this to inherit from agent. And this is basically, you need to understand that this is like a master's class. In the past, in order to set up a simulation, you had to set up an academy, and that academy was taking agent brains. So now academy is just a singleton. Basically, it's just like a master class, just like the agent. And basically each agent that you create inherits all the functionality from that singleton. So if we do this, basically we don't have these errors, because now we're working with the proper code, basically the proper functionality. So here, the first thing that we are going to do, we're going to say that C agent.
If the error hasn't gone away, should I just reload?
Which error?
The on episode begin isn't recognized.
And did you change the agent and can you share, let me see if you can share your screen.
Maybe if you try saving it, it might work.
Yeah, also try to save it.
No, still.
Mine has the same problem, but was a check. I had a typo on the on episode. Check if it's capital or not.
Yeah, so I will put this bigger so you can see the code.
Oh, here you go. That's weird. Thank you.
Okay. So now we will basically when an episode begins, we will reset the the position of our agent to excuse me, to like an for example, like the 0, 0. I mean, you can set the position of the agent to 0, 0, 0 if the position where your agent is now is 0, 0, 0. I know that yesterday we set it to a different height. So basically you need to return it to the position that you have it. So it is convenient that your agent is always in the 0, 0, 0. So you will write less if you do that. I will explain it in a second. Because what we want to do now is set agent's initial position. And for that, we will do the transform that local position. And this is also that I need to explain now, vector 3 dot 0. This means that every time that the episode starts, the settings of the transform, basically what you see here, we are accessing these values, the position will be 0, 0, 0. And one time when I was explaining this, a person, like a student, asked me, why are you using local position instead of position? And I said, wait for it, and you will see it when we finish actually writing the code, while it is convenient to do this instead of just like writing position. That is this. It's not position, position. Basically, this also works. This is like a global position, but we will use local position because one very important reason that we will do later. Also, we need to set random position for the target. I will upload this project also with the YouTube video. I will set a GitHub for it in case you get lost. So this is why I'm also commenting the code. So we will say that target, that transform, that local position, and here we will do some trick. We will say that we need to pass a vector, new vector 3, and we will use random that we can use random range. Okay, we will do one thing so this doesn't give us an error. If you go to imports, let's write one thing using random equals unity engine dot random. Yes, this is correct. Yeah. So sometimes if you're using like system functionality, you also have a random from the system, so it can give you like an ambiguity in the code. So in this case, we want to use like the unity random just for the sake of some consistency. This gave me an error. Why? Oh, it's giving me also an error. I don't know why I have system numerics. Yes, okay, now it's okay. I don't know why it added automatically something that was called system numerics. So we give a new vector 3, where the parameter, in this case, we are moving an x. We will see there is a random range between, and here we need to check what is our range of motion. So right now we're at the 0, 0. So we will say that our target, not our agent, sorry. We will do this for the target. The target right now is at the position, let's say 6.5 maximum to the right, and to the left it's minus 6.5. So we want to generate random numbers between 6.5 and minus 6.5. So to do that, we will write here minus 6.5 and 6.5, and we need to add an F because these are float numbers. And here we will do also one trick. Basically, we want to have the probability that that you get like 50% chance of getting a number that puts the target to the right, and also 50% chance that you get the object to the left. So we will multiply this by 1 or minus 1. So for that, we will do random that value, and we'll say less or equal to, we will say 0.5, and this will we'll say that this is 1 or minus 1. So basically, this line of code is saying that you're giving the probability that this will give you each time like 50% of like a positive number or a negative number. So it will give you a 1 or a minus 1, right? So you don't want like all the time, for example, you don't know if that's going to be the case, that you get like more negative numbers than positive numbers. So that will bias the training of your agent. And basically it will learn, if you get more negative numbers, it will force the agent to go more to the left, the negative X, instead of the negative right. And we will give,
wouldn't it be the same if I do random range 0 to 6.5 and then multiply it with this?
Sorry, again?
If I do random range from 0 to 6.5 and then multiply it with this 1 minus 1 equation.
Yeah, so as I was saying, that because you're given a random number, I mean, a good way to make sure that you get like 50-50 chance of getting a negative number and a positive number, and you don't get like more positive than negative or vice versa. Basically, you need to do a trick like this, because again, if you get more negative numbers, basically you will bias the training. So the agent will learn to go more to the left than to the right.
Yeah,
This is basically everything that we have here. This is the parameter X. Yeah.
yeah, but I think the point's like, I'm not sure if I'm confused, but I think your random range isn't that random uniform. So in that sense, you should. I don't understand why you're doing like a random uniform between negative and positive, and then you're multiplying by another. I'm still confused about the second part. Why do we need that part?
You will see it. We will plot the values, and you will see it.
Okay.
Actually, we can.
If it's 0 to 6.5 and then you do the multiplication, I think that would.
Yeah, actually, yeah.
Also, that would.
Yeah, let's leave it like that. Yeah. You're right. So, where was I? With this, basically, we said the basic stuff that we need at the beginning of each episode. Now, we will do something that is like very important. That is the observation collection. So basically, we need to tell our script what are we watching, so we can take then the decisions. So in this case, we will do public override collect observations. If you write collect observations, it will show you the autocomplete. By default, it gives you this. We will delete it. And here, basically, you have, this is why we're using the ML agent sensors, because basically we are adding basically the observations to this vector sensor list. And in order to do that, what we need to observe first, what we need to keep an eye on, is always the position of our agent and the position of our target, right? Those are the two basic things that we need to keep an eye all the time. And in this case, we will do sensor.add observation. And the observation will be C agent that transform that local position. Dot X, because we're just watching right now the X component of that position. We don't care about Y or C because we know that those are 0. And this is also important because at some point, you see this has like another ways of adding observations. So you can add, for example, Boolean observations. You can add just a float. You can add an integer as observation. You could add quaternion. Quaternions. You can add vector 2, for example, vector 3, or whatever, like whatever you want. So you just need to know that right now we are, by doing this, we are incrementing our observations in just one number and one unit. If we were adding a vector 3, we will increase our observations in 3 units. If we will add, for example, a quaternion, we will add like even more parameters, like 4, I think is a quaternion, I don't remember. So if we're adding a vector 2, we're adding with just one line of code 2 units. And this is like, what is this? I will explain after we write this line. So we need to also add an observation sensor that add observation target that transform that local position that X, because that's also the thing that we are going to observe. So I will comment this. We observe X position for the agent. We observe X position for the target. Perfect. So if we build this and we go back to Unity, we can see a couple of things. We have the speed, and we need to add a couple of things so this basically can work. We can go back to our agent, the ML agent object, and we need to add another script that is that comes with ML agents that is called behavior parameters. Remember, if you click here and add components, and if you write behavior parameters, and it will show you this. And here's where you configure a couple of things that are crucial for our simulation. So in this case, basically, it will, we need to give a name about what is our behavior name. Remember the diagram that I showed you before, where you can add, like, you can have multiple behaviors, multiple agents, and so on and so forth. This is like a very basic thing that you do. We can call this like agent cube behavior. It will be like the agent cube behavior. And this is very important because right now we determine 2 observations, and those observations are float numbers. And basically, I was telling you that when we add, for example, a float number or a vector 3 or a vector 2, you increase the units of this observation, the number of observations. So in this case, we're just watching 2 numbers. So we need to configure this to 2, right? This is the space size of the observations. We won't care about the stack vectors yet. Probably we will care in the 3rd exercise. So basically, one of you asked, can you explain what we're doing first? We will do 3 exercises that we will try to combine in the end. Basically 3 smart agents that we will try to combine and collaborate. So I will explain this in a more advanced example. Here, this is important. We are basically telling our simulation if we are using a continuous space or a discrete, space type. A continuous will give us values that are basically decimal numbers, usually normalized. That means between 0 and 1. Or discrete, it can give us like a 1, a 2, like an integer number, right? It depends on the situation. We will use both. For this simulation, we will use continuous, and we will say that our space size is just 1. This means that it will give us just like either negative values or positive values. We will understand, here, the space size. We give it 1. The other parameter that we don't have anything, like we don't have nothing here, and basically it's giving us a warning. It's saying that there is no model for this brain, so you cannot run the inference. Basically, you cannot run this simulation because it doesn't have like anything. But you can still train. That's important because that's exactly what we are going to do next. You can use your CPU or GPU. I was reading about this, and for this case, I think like also I tried. So just so you know, I try using my GPU or my CPU, and actually sometimes, and I was reading, I don't know why exactly, that for example, like PPO, that is the algorithm that we're using, doesn't benefit much from GPU power. So the faster your CPU is, the faster you will train. I don't know if that's true. In my experience, it's almost the same. So if you leave it on CPU, it's okay. And the behavior type, you can have either inference or heuristic. We will also check that later. And the team ID, that's a parameter that I never use. So I will check and I will tell you what it is. Use child sensors. We don't have any, but just in case, it doesn't hurt if we leave it like this. So with this, basically, we don't get like any errors. We just get a warning, and we are ready to start telling our script what are our actions given the observations. So I'm going to save the project. I'm going to save the scene, and I will proceed to complete my script. So I will put this here. I will put this here. And here I will do public override of on action received. This is the method. It's on action received. I will put it bigger so you can see it. And here, basically we will set like all the actions, and also here we can set, for example, the rewards. Remember that figure where I had the agent angry or like happier, and then like super like happy because it was touching the target? We will do that here. Any questions? Am I being boring?
I have a question. So when you said that, so there was one variable that I didn't get it exactly. So the space size, when you set it into 1, you mean like we have only one dimension, like across the x-axis? Is this something represent that number?
Yeah, I mean, we will see, especially, yeah, we will see that you can have many behaviors and many actions. So right now, the only action that we're going to take is moving to the x-axis. Imagine that we are adding, for example, moving along a plane.
Got it. So it could be 2-dimensional.
Yeah.
The 2 number.
Actually, you can do it with 2. But also imagine that you add another action that is jumping. You can add another one. So basically, you can add this space type, the space size, according to the different actions that you.
Oh, so it's basically representing the space as we have in 3D space or 1D space or 2D space or 3D space in Unity.
Yeah, it's similar. You will see that there is a slight difference, and you can tweak it to do like more complex stuff. So we will see that in a minute. So here we will as I was saying, we will set our actions. So the first thing is that we need to set something that is like the, how can we call it? I'm never good with names. Basically, this is a float parameter, and we will call it not final. Yeah, let's say final distance to target. We can call it final distance to target. And here at the beginning of basically the execution of this, like in every cycle, we will check what is the distance between the object and the target. So in order to do that, we need to say vector3 dot distance, and we will say like target that transform that dot form at local position, and we are, yeah, we don't need the x, we are measuring here the actual distance, the Euclidean distance, and we will say C agent that transform that local position, and this will give us a float, basically the distance between those at the beginning. After that, we will basically modify, we will create a new x value. So in order to take the action of moving to the right or the left. So in order to do that, we will declare float x new, for example. And we will say this is C agent that transform that local position, that x, the component x. And here we can, what can we do here? We can, let me see, because I did this before. Let me check my notes. Oh, yes, I did this. Okay. Sorry, I don't remember everything from memory. So we can here take the vector action because we know it's going to be a value, like a decimal value. And we can say something like vector action 0. Because remember that we have only the size of this vector action is just like 1. So we will take that specific value and we will multiply it by the speed that we set here at the beginning, 3. We can change it later for our simulation, for example, but for training, I think 3 should be okay. And we will multiply also this, so it increments during time by time that delta time. For the ones that are not familiar with time delta time, so basically that's the difference in time between the current, I think it was the current frame and the previous frame, because you know that this is running constantly in a loop. So basically it measures that. When you have physics simulations, we are not doing like physics simulations. Sometimes you have the fixed delta time, so you don't get like errors in those simulations. Instead of delta time, it's just like fixed delta time. So this will give us a new value for this will give us the value to basically specify. Let me put this a little bit. Let me add the notes here. We check the distance from target to object. We get a new x value for the agent. And here, what we can say is, yes, we can assign this. We can set like C agent that transform that local position will be equal to new vector 3. And here we can say x new, comma 0, comma 0. So basically now the agent will take that value and it will move. So what will happen here? You see that this value that at the beginning will be like super random, super chaotic. What's happening inside basically is that you will have like a tree of possibilities where you can move, in this case, like to the right or the left, different moves. And according to the value that the loss function in this case is indicating basically if this is the Q value, if this is like a good enough movement towards the goal. And in time, after like many repetitions, you will see that the agent will start behaving. First, it becomes like being really erratic, and then it will just like by magic will start like moving, because it will learn that because we're trying to maximize reward, it knows that it can get more and more rewards by getting closer. But once it touches the target, it knows that it can get like even more rewards. So it gets like really hungry for rewards, and you will see that this works like magic. So now that we assign this, we need to check again the distance, the new distance to our target. And here we will say that float, we'll call it distance to target. I think, let me check my notes again. Yes, that's exactly what I did. Distance to target, and this is a vector 3, and we can copy, actually we can copy exactly this line here. Because after we apply this modification, here I forgot to say it, we assign the new X position to the agent. We need to check again what is how big is that distance. And here is basically when we are finally able to set the rewards. We will say that if the distance to target is less than the distance to, final distance to target. So basically, if we're checking if the distance decreased or increased, right? You understand this? If this final distance got bigger or smaller, we will say that add reward. You have a function here, and we will give this a small number, like 0.1f. Right? If the distance got smaller, we will add 0.1 to our reward. Else, we can say, what we can say here, we can say that add reward, and here we can give a bigger number, not too big, 0.3f. If you want, basically, if you see, you can play with these values. You can check.
Sorry, Diego, shouldn't it be minus 0.3?
Oh, sorry, minus 0.3. Thank you. Minus 0.3. You can play with these values. Sometimes you may want to start with the same, for example, to give like 0.1 here and 0.1 here, just to see what happens. And sometimes if you see that it's getting like difficult for the agent to reach the goal, in this case, you might want to punish bad behavior, right? It's not just that I'm not giving you the treat, but I'm also like hitting you because you're being a bad agent. And also you can, of course, increase the reward. The only problem is that if you increase the reward here, you might get problems like at some point the agent could get like too comfortable with just like getting closer if the reward is too big and never touch the target. So, I mean, this could happen here as well. So we will add one more thing to our code. And with this, we will be ready with programming the first agent. The start, we will leave it like that for now because we need to add one more thing. Here we will say, what can we say here? No, actually, let's do one more thing. Let's just save this. Let's compile it. Let's go back to our Unity environment. And one thing that will happen is that once I move the agent and it touches, it needs to trigger an event. Right now, we're not doing anything with that. So we need to add a component that basically detects that collision. So if you select your agent and you go to add component, let me collapse all these things. If you add a component, we can have a collider detector. We will add a new script that the name will be collider detector or collider. I mean, don't call it collider because it can like basically get mixed up with the collider from Unity. So we can call it collider detector. And we will now say, create an add. I don't know why my computer did that. Okay, now here it is. And if I double click, I go to Visual Studio Code. And this one, I don't remember how I specified it. Let's check my notes. Oh yeah, this is a very simple script. Let me delete those things. We will set a public Boolean. Actually, yeah, it needs to be a public Boolean. So basically it's true or false. And we will call this is collided or is hit or whatever, or did hit or basically boom. You call it whatever you want, it doesn't matter. I don't know if this is even like correct in English, is collided, but whatever. So we will set this variable from the beginning to false. All right. So this variable will store the information if it's hitting the object, the target, or not. And we can get rid of these methods, the start and the update, and we can say that this is a public void on trigger enter. This is also like a default function from Unity that will basically raise a flag. Basically, it will tell you if you hit another game object that has a collider. This is why basically it has here that basically takes the collider name. It will take that component from the other game object, and you can access the characteristics of that object. So here we will say that if, and I don't know if you remember this from yesterday, other that tag, sorry, compare tag, we can call this, how did we call it? I think it was target, like lowercase. We will set is collided to true. So again, each time that we hit the target, because the tag of the target, I don't know if you remember here, the tag of the target is target, lowercase. This should basically trigger this this change from is collided to true to false, right? Is that clear? Okay.
So one quick question before we go further. So that other that you have here is something like built-in component, or we should actually introduce it as a public game object
No, it
in this
will,
script?
because basically you're not like, let's say, like hard coding this. So any this method will take like any it will return the other as any object that you touch that has a collider. So you can have 1,000 objects with colliders in your scene, and if you touch 1, 2, 3, blah blah, blah like 1,000, and it will return like the other for that. Basically, it will return like that component from
That object that collided. Okay, thanks. Got it.
Do you need to activate the is trigger in the box collider for agent, or will that work without it? Also?
For the target, you need to
Okay.
So in case you want to, I mean, we're not doing it right now, but in case you want to check the collision with one specific game object, you can do just like tag. And you can give here, like, you can give that object like any tag that you want. So in this case, we're just doing like compare tag. So it will compare the tag, and if the other one is target, it will trigger this. So with this, we are okay. And now we can go back to our cube agent, script, and we need to set a couple of things. Because we are controlling from this, let's say, like general controller, all the things that are happening, we also need to get a reference to that collision detector. So here, reference collision detector, and we will call this collider detector. So you see now, if I write collider detector, it detects that this is a class. And we can call it CD. Basically, you need to write this. You need to write the same name of the class that you gave it here. So this is a collider detector. And what we can do, I will move the start method here, just because for the sake of like organization, because we know that start basically executes once at the beginning, and we will say that CD is equal to C agent that get component collider detector, sorry, like that. So now we are getting access to, where is it here? We are accessing this component of the game object agent. Is that clear? That's the way you do it. Basically, you get the component, and then you can basically read the public variables. You can play with the public methods, and so on and so forth. So now that we have this, on episode begin, we can do the following. We set the local position of the target of the agent to 0. We set a random position each time for the target. And also, we need to reset the collision parameter. So we can say CD that is collided equal to false. So resets the collision parameter to false. Right? So in each episode, you know that you're not colliding until you collide. You restart the episode and you basically set it to false so it's not colliding again. Why are we doing this? Because now, if we go to the update function that I left here, update with an uppercase U, we can say that if cd dot is collided equals to true, and we can finish our episode. And here I will basically, someone asked me once, like, what is an episode? Basically, an episode is just like the frame of time that you have that has, because PPO, basically what it does, it has like a specific number of steps of running time. Because remember that PPO, the difference, what I explained yesterday, that you get a batch of observations and then you just get rid of those. So basically, you right? So basically you need to perform this in a limited amount of time. So also this is a parameter that you can tune. If you see, like, for example, that I will explain, but what might happen, for example, is that if we give like two little steps for an episode, the agent might get lost because it tries to approach the target, but it doesn't have enough steps or enough time to the simulation to actually get the target. So that could affect also our simulation. So here we will say an episode. But as I was saying before, we need to also give an incentive. So we can not just say like, okay, you touched the target, you reached your goal, good luck, you have been like a terrific agent, you did it. We need to give some reward, right? We need to give the treat. So in this case, we can also add an add reward, and we can try with something like 5F. Right? This is like a final big reward, the treat. Right? With this, basically we finished programming our first basic reinforcement learning agent. But there are still a couple of steps that we might want to take. But those happen outside Visual Studio Code. So make sure that you save both or build all so you don't get like any error. I'm going to minimize this. It's giving me a warning because it's saying that the random range float is obsolete. Oh yeah, I just need to change it to, it's just a warning, whatever. We will fix it later. So we see that this is our brain, our behavior parameter. We need to add also something that is called decision requester. If we go to add component, and if we write decision or DE, it will appear in first place here, decision requester. This is a script that tells, I don't remember if, yeah, it's like a small script that it will tell, you can modify the range of here. So basically it's how frequently our agent will make a decision given the number of steps. So how fast it is to think. If it thinks too fast, sometimes it can go like really crazy. If it thinks too slow, it will not be fast enough to catch up with the simulation. So basically, this is another parameter that you need to tweak. Again, like every machine learning model that you have used before, put this here so we can see each other. You need to know that most of these like more complicated models are really like parameters acceptable. Someone said that has been working with generative adversarial networks. Those are super sensitive to parameter tuning, to the hyperparameters. In this case, it's not that big of a deal in terms of that you can play. And also now that we have the opportunity to simulate and basically train inside the editor of Unity, that didn't happen when the first versions of ML agents, we can also tweak on the fly some things. So we will see how this works. So now we have the ML agent, the decision requester. We added here, we added this to this to the controller of the scene and not to the agent itself, because basically this is our neural net. It's not the agent. The agent is just an object. So we are good to go. We will finish and we will leave this training, and then we will take a break of 20 minutes. That will give us enough time to actually get some results. And when we return from the break, we will do something more complicated with this, a specific example. So after that, we will explode into like a realm of more complicated stuff. So what we need now is to specify a, I don't know how to pronounce it, but it's YAML file. It's a configuration file that the simulation will take, and it will know what are the parameters to train this. But also, I will mention something now. Probably I should mention this later, but when you train ML agents, we do this scenario and we use local position, because the more agents you have training the same thing, the faster and better quality the training is. But that will depend on how fast your computer is. For this simple example, you can have only this scenario, but if you get like greedy, and if you want to get like better results, you can just like copy this, repeat it, copy it again, basically do exactly what I show you in the video, and you can copy it as many times as you want. So what's going on here is that each scenario has let's say a controller that works independently from the others, but they all contribute to the model, to the general model that will learn this. So that is actually pretty cool. I showed you yesterday in the presentation that Unity is also adding the dots paradigm programming to ML agents. That is like a new paradigm for programming objects in Unity. And that will give us the possibility of training thousands at the same time with no, basically like super efficiently. So in this case, for example, I don't know, you can do like 10 or this, and you will see this guys moving. And because we're using the local position, basically now the local position means that the local position is related or determined by the position of this object here. So if we use global position, it will use like the global position on the environment. So we don't know if this will go like out of bounds or not. So if we use local position, we know that this will always move up to here or up to here. Sorry, that the target, so the object will never fall. So yeah, I will leave it with 4 agents. You can add more if you want. The faster your computer, the better. So how do we do that? If we download, let me see if I have one file here so I can explain you.
Yeah.
Yeah.
quick questions while you're talking about this, because you mentioned before GPU, and now we're going to talk about maybe batches of training and also your copying things. So I'm curious, like my two questions are one, like, are we supposed to use, when you do this workflow that you set up an environment, agents, is there a way that you use prefabs to make sure that you don't need to, if you're going to change something, you don't need to delete, copy again?
Yes.
And the second question is like, because right now you're copying, but like when you're doing, you're going to set up the batches on the file. How does this number that you're seeing in front of you relate to the training?
Do you mean like how many agents? Like how many scenarios?
Well, my question is like, because you have a number that's like batches, like there's going to be how the batches for your neural network for training. And another thing you're doing, that's another number, you have 4 in front of you. Are these like the, let's say, the starting states for the batches? What are these for the configuration that you have on your screen?
The way that I understood when I was doing the research when I was started using ML Agent is that you can have, for example, 100 of these scenarios, and it should, for example, if you set this to 256 batches, it will multiply this by 100. So basically, it should do that. So basically, this is why I'm saying like the faster your computer, the better. It's not that it will divide the batches in the amount of scenarios that you have. If I understood your question correctly.
Yeah, but so let's say you have like you have only 2 copies, and they have 2 starting points. Like the agent maybe is on the left one and the middle in the other one. Does it mean that, and you're going to train with, let's say, batches of 64? Mm-hmm. Does it mean that every sample in each batch is going to start with one of those 2 positions, or is that randomized? I'm confused if this is like the initial setup, or you're actually constraining your batch to have like 4.
Do you mean by these 4?
Yes.
No. You will see
what's the point of having this 4?
Because I mean, the way this is what I mentioned before, like the way ML agents work and get better. Basically, this is something that the Unity people did in order to train with better quality, because we're watching, the way I understood, the way you are collecting observations, the more agents you have, the more experiences you will have that will train the model. Right now, this is just a number that I came up with. This will not affect how I configure the training. I could have like 200. So it will not modify the hyperparameters that I will give to my simulation. Basically, each of these are just independent, but they will all contribute to the weights of the final model that I will use. So, I mean, we will see it. We can go like deeper after we train, or after the break. So we are in time. But it's a really good question. I mean, I will try to clarify it better. So let me see. I think I have a file so I can show you. So we can copy it here.
So all of the copied agents are using the same policy per episode?
Yeah.
Okay.
Okay, here I'm opening a basic configuration file that I think it did open it. I want to draw. Damn it, it's not opening. Give me 1 second so I can open it maybe with Notepad, with WordPad. Oh, sorry, I was opening the wrong file. Now we're checking. Now, okay, this is the training file, the training configuration file. It looks kind of like a normal. Oops, I lost my notes. But basically, what you do is that you need to set, as I was saying, like all the parameters for your training. For example, the batch size, like how many, let's say, samples you will get to train, like in each run of this. A buffer size, the init steps. Let me see where I have my notes because my computer froze. The other one would I have notes? 1 second. Damn it. 1 small second. I think I have it here now. Anyway, while I open that file, so here you can basically you can add or you can specify which algorithm are you using for the calculation of your for doing the training. Here by default.
Sorry, do we have this file? Or
no, you will have to do
okay.
it. I'm just showing you. Yeah.
Cool.
So here, for example, the trainer, you specify if you're using proximal policy optimization or if you're using SAC, that is soft actor critic, that we will use in the next sample. I mean, we can use it with this, but first I want you to see how PPO works. And these are like the parameters that that we need to tune. So for example, like how, for example, the extrinsic parameters and the reward signals are affected. What I want to do, because I don't want to lose time, I want you to copy in a text file what you can do, and I will explain after the break. So we don't, basically we start training now. You can write a new file, and I think you can do in Visual Studio Code. I don't know if it lets you do it. Or you can do like any text editor file. Let me, that's something I didn't install in this computer. Let's say WordPad. And you can basically write your first configuration file. That's YAML. So why is it called Agent Cube is because our behavior inside Unity here, our behavior is called Agent Cube. So we should take this name, copy it, and in a hopefully WordPad, we can do Agent Cube 2 points, and we need to keep the indentation. I will copy here, put this half screen, so we can start writing this, not with uppercase. So again, I will explain this after. So I want you to, I can send you the file also over email. But if you want, you can train this, and we will explain, we will spend a couple of minutes explaining what are these parameters in detail after the break. So I want you to start training something right away. So I will, let me send you this file through email. I'm sending you the email right now. Reply all. File for training.
Diego, is this based on the release 2 or 3? Because I'm checking one of the examples in the GitHub repository that was edited around 3 weeks ago, and the syntax is slightly different. So for example, you have here trainer semicolon PPO here has trainer type. So I think they somehow changed the syntax.
Let's see, I didn't check that. I'm using what
Okay.
I have for 2. So let's see. I mean, if
Okay.
there's a difference, we will figure it out. So
Thanks.
you're welcome. Let me again. Oh, here's the file. You will get the configuration file on your email. Okay, just sent it to every one of you. And what you need to do next is you need to go to your famous Anaconda environment. You can activate it by using your interface or your terminal. I will do it like the easy way. Sorry. So we go to Anaconda and environments. You can open terminal and you're in your environment. And you need to navigate in your environment and your terminal to the folder where you have your files or your configuration file. So what you will do after you get your the file that I just gave you, for example, you can add it here in Unity. You can create a new folder, config file or config, and you can drag your configuration file here. And by doing this, the thing that you need to do, you need to copy this path. Yes, this is the path. So you can copy the route and it will take you to where the config file is. And it's as simple as doing this. ML agents. It's ML agents learn. Sorry, it's not that easy apparently because I forgot. I haven't done it since yesterday. So you do ML agents -learn. Then you basically need to point to that configuration file. So this is basic that YAML. And then you need to give it a run ID. Why is this? Because basically this will save a couple of things like the summaries. So if you can, for example, use TensorBoard, that we will look at it after we train. You can also, it will create like the model and the weights and basically all the files that are needed to use it later inside Unity. So we write run ID equals, and we can call this like whatever. For example, first run, right? So if I press enter, hopefully it will do it. It's not doing it. Now it's doing it. Oh, it gave me probably an error. The option agent cube is invalid. Why?
Also, did everyone receive the email
No, I haven't received
Yes.
anything.
for the
I
YAML
haven't.
file?
Yeah, I received it.
Yes, I received it.
I sent it to everybody. Please check. It should be from my MIT email. Probably you're right. It's giving me an error because of that. I will check it. It should not give me an error.
Is that a typo?
It says that the configuration is bad. Like, is training type like this?
No, there's an underscore between trainer and type.
Maybe this is it.
Yeah.
Let's see. Because I was using two. You see how things change like super fast, so it's kind of annoying. They were promising that things won't change that much after release 1, but apparently they.
I think it's just that you have to like add it in a new behaviors tab. It's like everything is now nested in behaviors instead of having it be individually your your specific. Yeah.
Could be that. So behaviors, and we will. Let me see if this works. Probably this is it. Sorry about that. This should be the right file. Let me delete this one. Okay, if this is okay, hopefully. And I don't know why also it's taking a long time to. Usually it's fast when it trains. So let's see what's going on. It should appear here like in ASCII characters, the Unity logo. And then you just press play and this will start training. So let's see what happens. No, again, it gave me an error. So let me see what the error. But it's invalid. Maybe it's because of the name that I give it. Agent cube. Okay, whatever. Let's do one thing. I don't want to. Basically, I want to split in the session now, so we can take a break of 20 minutes. Let me see what the error is, and then we can train it, and you can see it. I mean, it's not important if you train it now. I just want you to see what's going on, so I can explain, and then we can make the more complex behavior, because this will be the foundation for the next exercise that we will do tomorrow, and also I will explain what I need you to do for tomorrow's session. So let's take a break of 20 minutes. At 4, we will return and we will see how it progresses. Shoot me an email if you didn't get the file. So now coffee break, and I'll see you at 4. Okay.
Could you leave the command prompt that you had, just the syntax, open on your screen?
Yes.
Cool. Thank you.
Could you open the YAML file for me? Thank you.
If you can just copy paste it, the whole thing on chat, I think it'll work.
Oh yeah.
Because I'm not receiving the email.
Wait, let me first copy this.
I just got it.
Yeah, it will eventually arrive. This is what you need to run in case you have the file. I will leave this here, but I will check what the error is. Okay, you will get the email. I will send it again in case you didn't get it. So let's go for a break. Huh?
Also, can you please share the code, because I missed it at some point. So if you can share that as well.
Okay, I will.
Thank you.
Welcome.
And it seems that the YAML file has some problem. Could you
Yes, that's exactly what is going on. Let me see now in the break to see what the error is, because it should not give me an error.
Yeah,
So,
I have some experience with it, so maybe I can have a look at that.
okay, yeah, if you can. I mean, I will check it also. So let's check it after the break.
Sure.
Can you hear me?
Yeah, we hear you, but it's really, really quiet.
Oh, yes, I know why. Because I have. What about now?
Slightly better, but not
Yeah,
that
much
great.
better.
Much better. Okay. Let me check if I'm using the right microphone. Shit. Okay, so I'm sorry about that. I don't know if any of you had like a chance to test with the file and if it worked. I don't know if it's different because of the operating system, that in my computer is not working
I guess it's because of the release version. I have a version that actually works on this environment, and it's following the release 3 conventions, which change the structure a little bit.
Okay.
I managed to get it running with a different format of the YAML file, but it throws an error once it gets into Unity. So you can get the TensorFlow communicator open, but then it says it's not set to the right. It's not set to the right object. I have a question. In the YAML file, when when you're saying agent cube, what is that referring to in Unity? Is that referring to, like, because I think it's having a, do you have to name it after the game object that you're affecting?
To the behavior
or the
name.
The behavior?
Yeah. So the behavior name, can you see my screen now?
Yeah.
Yeah, so yeah, it's pointing to the behavior. So can you share that file in the chat so I can test it? So we can.
Yeah.
I appreciate it. So So now we will do something that will build on top of this, and it will be the foundation for the exercise that we have tomorrow. That is, I won't tell you what it is, but basically it will start with the same thing and it will add more complexity. So, did you share it? No?
Sorry, I'm trying to, almost there.
That's fine. In the meantime, what I want you to do.
So,
is,
just one thing about it is it's downloaded. The settings aren't the same as yours, but it's the correct format. So if you change the parameters with yours, it should work theoretically.
Let's see. Let me open it and. Okay, I see what you did there. Yeah. This is like the format. Okay, let me see if I can make this work, and so we can move on. Let me copy this here, and it's called trainer config. Trainer config. Sorry, it's diversity assets config file.
We still see your Unity screen. Can you share the Visual Studio?
Yeah. Give me 1 second. Okay, now it's working. Yeah, it was a configuration. This is something that changed. Let me share my full screen now. It's the screen 2. Can you see the command line in Unity now?
Yeah, we see it.
Okay, so this is exactly what happened in my Mac. It was like probably like a change in format between version 2 and 3. So I installed 3 obviously here. In my Mac I had 2. So we will figure that out. You have the configuration file from, sorry, who shared it?
August.
August. Thank you, August. You saved the day.
Mine still doesn't work though, so maybe try running it.
Okay, yeah. Actually,
but you can at least get to here.
So let me press play and hopefully it will work. I don't know why also in Windows, that's what I hate. It takes a while. And heuristic method call, but not implemented. Ooh.
Yeah, that's.
Let me just do 1. Let me turn that off. Here is continuous. The behavior is by default. It's not that. Continuous. We have this configuration. Seems okay. Let me check the configuration file again.
That file worked for me. Mine seems to be training now.
Yeah, it's training, but you have to check the Unity console to see what's the warnings and errors.
There isn't any errors from what I could see.
And you didn't change anything from the file or the YAML file I sent?
Let me just double check.
Oh.
Yeah, check that. I don't know, why it's giving me that specific error, because we're not setting this to heuristic. We're not calling any heuristic method here. That is weird. Of course, this will give me an error because I don't have a brain. Probably in real life, I don't either have a brain, so this is not working. Keep agent, agent, target. The agent is okay, the target is okay. Weird. Where is this giving me the error? In the agent class, no. Now let me see if I can fix it in like 1 minute. Otherwise, we will move to the other part, because I mean, it's not the big of a deal if it's not training right now. I want you to see the other example that is like the one that we need to get working. That it will change also the way the config file is working. So, oh, I had it in GPU, I have it in CPU now. This is continuous. Okay, let me see if I can run it again. Also, for some reason, it's not, you see if I press play, yeah, it's not communicating with Unity, because here you should see the config file. So let me try one last thing. I will erase the behaviors. And I will just unindent this. If this doesn't work, I don't know what else to do. Probably I do, but.
So I managed to make this communication, and I got that message and a Windows side that says like something is trying to connect over the network. So it's running, but on the Unity, like I got that Unity message on the command prompt and other stuff, but it using part of my GPU memory. But it says there's a message on the Unity side that says hold on, and then it says it's busy for 1 minute and something. And I think the problem that I had initially was about the syntax of that YAML file, because I was using the version 3, and I think you're using version 2, the release 2. And I think in the version in release 3, they actually put everything under kind of a special hierarchy, and that's why you got those errors with the YAML file. Yeah, but right now the challenge is that it's communicating and doing everything. Other than that, the problem is that it's not getting feedback from Unity.
Mm-hmm. Yeah, remember, I mean, for some people on Windows, what I don't know if that happened to you. You know, you see that window that shows you do you allow like the security thing, like the firewall? Do you allow like?
Yeah. Actually, that showed that message, and I permitted to do that.
Okay.
Yeah.
It is. Yeah, it is a weird mistake. For me, for example, what worked right now, I did this. This is the configuration of my file. So basically it was the same as before. You just need to indent after hyperparameters, basically the parameters, the network settings, the reward signals, and then leave everything as it is. So we will figure it out. I mean, we have, sorry, we have 40 minutes. So I want to explain this like really quick, and then we will move on. Right now, my agent is training. For some reason, it's not training very well, but also that's part of something that I'm doing here. I'm using PPO, that is proximal policy optimization, and PPO usually takes longer to this new algorithm that we're going to use, that is called soft actor critic. That is a version of actor critic model. So if this is not performing very well and it's moving away, actually this should be long. I don't know why it's moving that far away. So you see now that the agent is moving. Now it's getting closer. And again, this is like in relation to, for example, how many of these scenarios you have to train. you have for training. So you see now it just learned how to approach the cube. So it touched it and now it got closer and closer because now it just learned how to do that. The more scenarios that you have, the faster it will train. So if you have, I will share all these files. I will share the full project. So hopefully it will work in your computers after this. So the configuration file is basically you can have this YAML. Now I know how to pronounce it. I didn't know. I just used it for many years. I don't know how to, now I learned how to pronounce it. The YAML file can have like many configurations for many behaviors that you can have. And in this case, for version 3, it's trainer type, and we're using the PPO that I explained yesterday. And here you have the parameters that usually are, for example, the batch size, the number, this is the number of experiences, basically. And the experiences are basically like the movement, like in terms, like simple terms that the agent is doing. So basically those are experiences that happen in, so basically these are the number of experiences that the agent is collecting to perform this. There are other parameters, for example, epsilon. The epsilon here, 0.2, is how rapidly the policy can evolve during training. So remember that we said that we are trying not to change the policy from one state to the other. Like, don't make drastic changes because this could like shoot the agent or like whatever that we're training, like, and giving us like more random results and something like undesired results. So this is the parameter. You have like a lower epsilon or a higher epsilon, it can produce like changes like that. You have, sorry, I'm reading my notes here because of course I don't know everything by memory. You have lambda, that is a regularization parameter. We can go in more depth after that. We have the learning rate. We have it here. And this one specifically, no, we're not setting, oh yeah, we have the learning rate here. It's like how fast the agent learns. So we can also play with these parameters if we wanted to learn faster or slower. Sometimes, I mean, it depends on how do you see that is the evolution of this training. So for example, right now, for some reason it stopped. I pressed something that it stopped. So anyway, it produced, or maybe it just finished training. Whatever. So maybe we will, I mean, we will tune these parameters. Don't worry about it. I will send you the document with my notes about what every parameter means or is, or basically what it does. For now, what I want you to do, so we have at least this example. With one of the scenarios, I want you to just scale the floor. Let's give it a size of, let's say, 35 by 35 in the X and Y position, right? So now we will go three-dimensional, like, or B-dimensional. Basically, it will not be only X, but we will learn how to move this in X and Y. And I will show you one difference and basically how to understand also how the vector space and the space type work. So to work with this new scenario, actually, I will save this scene that now is workshop 01. After you do this modification, you can save as in the scenes folder. It was the sample scene, actually. I will save it as, let's say, XZ example. So now that we have this, we're ready to do like a more complicated behavior. But the good thing about this is that our base script won't change that much. So this is an example that basically start building on top of the same simple one-dimensional movement that we have. So what we will do now, we will keep exactly the same configuration, exactly the same. We won't do like drastic changes, but we will write another script for the agent cube. So what we need to do, the cube agent that we have here, we will create another C# script. Actually, I just realized that I don't. Okay, now everything is in order. We will write a new C# script, and we will call it cube agent. What can it be? XC. That's okay. I'm not very good with names. So we do another script, and we will copy. Let me close this and close this. We will copy exactly the same code that we have in cube agent, and we will copy it here. But we need to make one change. So instead of cube agent, we need to call it cube agent XC. So now this is a completely different class. It has nothing to do with cube agent, and we can modify it in order to so our agent has a more complex behavior. So everybody did this. Remember, copy the code into a new script, change the name of the class according to the name of the file, and we're good to go. Let me know if you didn't. I can send you the file as well. So what we need to do basically is increment two things: the number of observations and the number of actions, because before we had only right and left, and we were observing two things: X position of the cube, X position of the target. But now we need to observe more things, which are the movement in the Z-axis and also the position in Z for the target and the cube. So we have more observations. So this will make something more complex. And I will show you. Remember that in our ML agent here, we are using the space type continuous. Now, for the sake of showing you more stuff, I will show you how to use the discrete space type that will allow you to, for example, use a switch case type of code, so you can trigger specific actions. So let's do that. Oof, I have a lot of files open here. Let me close a couple. Okay. Can you see the code, right?
Yeah, we see.
Okay, perfect. So now, on episode begin, basically we will make just small modifications, and the small modifications will be that we are not just giving a random X to the target, but basically we can copy exactly the same to the Z parameter. So now, every time that we finish one episode, the target will move not only in X, but also will move in positions like in a circle, right? It will move from place to place. And this will be very good because this will basically drive the agent crazy at the beginning. And the agent will have to learn not only to move in X, but also like every direction. So once we have that, remember, we copy the X function that we have here to get the random value, and this here. We can change the parameters here later. We can add a variable for that. For now, we will leave it like that. But here's the important part. as I was saying, here we are observing the x position for both. So it's as simple as just copying this and change it to the third component of our vector. So now we are increasing the vector observation, the space size, from 2 to 4. Again, this is super important that you don't forget about this. That, for example, if we are observing a vector, we could have like floats here, and then we can observe a vector. Actually, we could have now just a vector 2, but for each of these guys, or vector 3, but it's the same. Basically, for sake of like simplicity, we're just observing x position and z position, right? And because these are floats, now we have 4 observations. That's the space size. And this is the important thing that we will change more dramatically. What we had before in terms of giving a new x and then assigning the new position, we will do something that I know probably is not optimal, but it will show you, basically I'm making this to prove a point that what if you have the possibility of assigning just like discrete movements, and force, for example, give another layer or another type of complexity to your agent to restrain the movement like chess type. This is why I'm using discrete right now. So you can say that for each action, you can only move like to forward, backwards, right, or left. So basically, it's like a very like mechanical movement that we can modify. I will show you what is the other version of doing this. So we keep the same, the distances, like the final distance and basically the two, like we measured the distance before, we measure it after we do something. And now we will say that we will create a variable, bar. We will call it action. And this will be equals to vector action 0. I will explain this because we need to configure one more thing. And just so you visualize this, we will add a debug.log. This is like the typical processing command for printing stuff in the console. We will say unity log action. So we want to see what is basically the value for the action that the vector action that we are getting in return each time that we move. And here we will program our discrete movements. So we will do a switch. And here we will, switch action. And here we will say that I always make a mistake here. Switch action. We will have a case 0. Is it a case 0? Yeah, it's a case 0, where basically this is when action is 0, we were getting a 0 as a number. And actually here it is convenient, just in case, before I continue, I will do math f that floor tweet. Just in case, because I'm not sure if this will give me by default a float number or an integer. Just to be sure, I will just force the casting of that number. So we know that we will force casting the value to get an integer That's it. So if we get a 0 from the vector action, we will say that Q agent, no, C agent, sorry. C, is it C agent? Yes, C agent. That transform that local position equals new vector 3. And here we can do cube agent that transform that the local position that x, and we can define, for example, like a step size for the movement. How, basically, what is the increment of the movement that we're going to have? So here we can set a variable that is called step movement, step move, whatever. And we will declare this at the beginning next to speed. Float. Actually, you can do it public so we can modify it on the run. We see that it's not very good. Move, and this will be, let's start with 0.15. So this means that our agent can move only 0.15 units towards the direction that we will set right now. Plus a step move. Here we will say that we're not moving in Y. And here is important because we are not going to give it 0. We're going to give the current C coordinate. C agent. I don't know why it's changing this. C agent, C agent. So if we get 0, we will move 0.15 units in the positive x. Then we will say, after you've done this, break, and we will establish the remaining cases. So we can do this. We can say case 1, case 2, case 3, and you can have as many cases as you want. Now, this is important for making it more. So in this case, I will name this move in x positive. We will set this to move in x negative. We'll set this to move C positive and move to C negative. And now we need to change this. So if we want to move in the negative direction next, we just set this to a negative. Here, if we want to move in C positive, we just change, we add the step move to it positive, and here we do the same, but this will be negative. Fantastic. So now we are adding options, more options for movement to our agent. And this is really cool because, again, I was saying that what if you have, like before, like you have movement not only in X or C, but you can jump. So you can add another type of behavior, for example, another case, and you can separate it to, let me set this to don't disturb. Okay, whatever. So you're seeing now that we're just giving like a little bit more freedom, but it will be a little weird what the agent will do, because it will move like orthogonally. It will not, basically you're not giving him or giving it or she like the possibility of moving diagonal. And that will be some sort of like homework for you. So if you can figure out how to do it. Okay, so basically everything remains the same. We measure the distance again, we give rewards, and here we can be a little bit more aggressive because now the environment is more like sparse. So we can give a little bit more incentive and say that the reward here, once you get closer, it will be 0.3. But the punishment could be like minus 0.8, minus 1. So you will make sure that your agent don't go crazy. And the reward, we can go to 30, for example, like a big reward after the episode is finished. Now, being this said, and with our new environment, new agent XC like ready, we can go to Unity and we need to configure what we have here. So now this is using the script cube agent. We don't want to use cube agent. We want to use our new script. So I can just add here. You can delete it because now this is a completely new scene. So what you have here, you don't need it. I mean, it doesn't affect the previous scene. So I will remove this component. You need to assign again the target and the agent. So you see here you have the parameters. Here we're not using speed anymore, so you can delete it. Maybe I can do something with speed, I don't know, later. We have the step move at 0.15. The good thing is that during training, you can tune this on the fly. If you come to the editor, we will see that. You can increase it, decrease it, and so on and so forth. The numbers of steps, this is also very important. If you set it to -1, it will be, I think, infinite. So you can, basically this is like the amount of actions, the steps that the agent will take. And we can set it to like a really high number or a really, like, I don't know, it's also like tunable. So we will start with 500 steps. And if you see that it's too little to get to the target, you just basically increase it. So you give more time to the cube, to the agent to reach the objective, the target. And here's the interesting part. So if we go to ML agent and now we change this to discrete, we need to do a couple of things. We have now 4 observations, like the size of our observations is 4. If you go crazy with this number, right now, I don't know why it's not yelling at me. Usually if you add more number here, it will tell you that you're adding like 100 parameters and you only specify 4 in your script. So make sure that you count well the things that you're watching. So in this case are 4 floats we're observing. Again, the stack vectors, we're not going to use it today. And the vector action, would you change it to discrete? In this case, we will say that, just 1 second, so I can explain this better. Basically, we're giving this, we're only having 1 branch, 1 list with 4 possible actions, right? So this is very good. For example, if you, let's imagine that you have certain actions and those actions are of different nature. So for example, one action could be just move on the plane. You might want to basically put those actions in 1 branch or assign or relate those actions to 1 branch. If you have, for example, like jumping could be assigned to another branch. So you can have, or you can separate, for example, horizontal movements from vertical movements here. So, I mean, because we added 4 possible actions, we want to move in 4 different directions. And basically we need to distribute this. It's like typical, like in lists. So in this case, I'm just going to go with, we want 1 branch with 4 possible outputs. And this will give us 0, 1, 2, and 3. Any questions about this?
Can you show us the script again? I get an error regarding this transformation for local position and the 4 different, yes. So I get a message that says an object reference is required for the non-static field method or property for the component transform. So I don't know what's going on here, but it gives me error for every single case that we have here.
Let me give you the possibility of sharing the screen. So we can
no, actually, I'm on 2 different computers, so I cannot share that one.
Oh, okay. Okay. That's,
sorry for that. Yeah, so I think I found the problem. Maybe that's the case. Yes, I got it. Sorry, don't worry. Go ahead. It was a naming convention that I made a mistake about. Sorry for that.
Okay, yeah. So yeah, like be aware that like using like the right semicolons and the colons and like other stuff. I will, again, if you have a problem with the code, I will upload it to a Git repository or maybe a Dropbox, and I will share it with you. So as you can see, like going from a very simple case, and this is why I'm taking my time to show you this, is not as complicated. And let's see what is the behavior, because right now I know that the file that August shared with us works. I will use the same file. I will not change a single thing. So the only thing that you need to know also is that when you run the training, you need to change what is the simulation name. What is the ID of the simulation? Why? Because let me show you. I don't know why they're trying to sell me a car. Sorry about that. After we train this, where is supposed to be the training files? Anyway, whatever. I just gonna name it like first run, like in this case, like XC run. And I'm ready to start training, and hopefully it will start doing something. So if I go to Unity, let's see if we can change, like, I mean, probably it will give me an error. So you see now the agent, like the target is moving. And while the target is changing position, the agent at first is just like trying to go to places. At some point, it's like falling to the infinity. So if you want, you can add walls with colliders to your environment. But at some point, you will see that as soon as the agent touches the cue for the first time, it will start getting so much better. So right now, of course, it's not doing it. Let me, so for example, in this case, you could also add a punishment if, like a negative reward, if the agent falls from the edge of this. So how would you do that, for example? Let's leave it training a little bit. I will say that, for example, if C agent that transform that local position is less than 1, it's less than 0, because you know that local position that y is less than 0, it means that it's falling on the infinite. And you can say that add reward minus, let's say, like really punish it, minus 10. And also, also we can end the episode here because there's no point that you continue simulating. So that is like super cool. You see now we're adding and adding stuff that are more like common sense. We are punishing because of this. Imagine that you're having, I don't know, something that is navigating. You could add obstacles, for example, and you can add also, if you touch an obstacle, punishment. So you will see that the object avoids touching an obstacle. But for that, I mean, this is a simplification of a model like that. For this type of behaviors, when you're trying to avoid obstacles, there is something that is called ray observations that I hope that we will have the time to, I will push like in the next few sessions to push forward to show you an example of using rays. So basically you add the capacity of like being a bat. You have like super ultrasonic powers. So again, apparently, I don't know if this is a Windows thing. Oh no, it's doing it. So you see right now, it's getting better, but something is happening. Oh, actually, it just stopped moving the agent. So that is weird. So probably, oh, let me see here. Oh, this is an error that I've never seen before. I don't know if it's my, yeah, because I'm using like a different version or whatever. Just let me kill this. I want to show you, because we have a couple of minutes left. What happens when I change the training? Hopefully it will do good, or maybe this is an assignment for each one of you. Let me check the config file. I want you to, after this, play with the parameters. I mean, of course, I will upload you. I will upload the what the parameters do, but I will change this. I will change the trainer type from PPO, from soft actor critic, that I will explain tomorrow what it is. It's like a slight modification, but it's actually really cool because this is a model that allows you to train way faster, like super fast. And it outperforms PPO in terms of what it can do. They are very similar, but they have like some differences that are crucial. So I save the file, and let me see. It's so weird. It lost communication with the Python. That never happened before. Let me train the thing again. Of course, with a different name. Oop, now it's giving me an error. This is weird. Now it's giving me an error. Ah, I know why. Because I am not using this file, maybe. Just 1 second. I think this is okay. Oh. No, it's giving me the error again. Why? Yep.
I had the same issue, but the error that I get is that it says the option beta was specified in your YAML file for that specific one is not available. So I think maybe the variable that you have in your configuration file are not valid for SAC.
No, I don't know. I mean, if I if I commented, I've been using the same default parameters in other occasions. Maybe that's something that they change again. If that's it, I'm not doing this anymore. I can't deal with these changes so quickly. I will do processing instead. Let me check. So you said that beta, that's weird because it's supposed to be, let me remove it. And let me change the name to this training file. Where's Unity?
So I basically copy pasted the sample for the 3D ball in their data set, in their GitHub page.
Mm-hmm.
And I just, the one that uses SAC, and it works exactly fine. So there's something in the file. So they have these tau or whatever, maybe instead of beta. So I'm using that one and it's working pretty well.
Okay.
Yeah, tau is specific to SAC. It's not in PPO.
Yeah. Yes, exactly. Yeah, you're right. Okay, so let me change that so we can train it. Where did I get the file? Here. In the meantime, do you have any questions? Yeah, you're right. This is tau. Is there any question? No, yes, maybe.
I have one other question. Sorry for bothering you again. So can I see the code for target transformation local position? It's in the on episode begin.
Yeah.
Thank you.
Here. So I just
okay.
did the same. So the same.
Yes, that's correct. I just want to make sure I'm not mistakenly taking XYZ in the order. Great. And since like I think at the beginning you set the Y value for the target to 1 in the file, but here it's 0, and I think that's one of the reasons. Like I think at least in my case, it results in like having the target inside the ground. So I updated that one.
Yeah, exactly. You're correct. This is why I mentioned it at the beginning of the session that it's good for, so you don't have to do extra code if you just position your target.
Okay, got it.
Yeah.
Got it.
Because for example, in this case, to reset the position of the agent, you just say like vector 3, 0, and that will lead you to the origin of the digital environment. So if not, you just have to do like new vector, x0, y something, and so you write a little bit of characters more. So this is more clear as a code. I will check because we are on out of time. I will check the configuration file. I just made the mistake of using like the old one, so I will check the format for the ML Agents revision 3, and it will be fine. I will send the project with these files, updated, working. So it should work like immediately for you. So I am using, so you know, 2020 V13. So if you're using this, that's fine. If you're using an alpha version, that is fine as well because it's more advanced. So I have a question for you. Did you enjoy today? I mean, even though I know that some of you still can't train, but is it more clear how to start programming an independent agent? Yes, no?
So I think that would be great if you could have some sort of like file that, just a text file that we can have actually for a website or something like that that you've set. And then we know that at each moment, which step are you covering? For example, when you were switching between the code, Unity, and coming back, it was a little confusing for me. So I made a step-by-step workflow that says, okay, we should do this, and then I had a kind of in-depth review of that one. Other than that, I think the only challenge that I have here is the fact that my agent is just running outward rather than coming back. So I need to fine tune that one. and I'm a little bit
I have
confused
the
about.
exact same problem, strangely.
Yeah, I'm having the same
It's
issue.
just kind of running out of the
It's
flow.
actually learning how to go away from the. It seems like it's learning how to go away from the target
Oh,
instead of
okay.
coming
So
to it.
I think
one
somehow
thing, like,
I'm confused about those cases. Like, how do we get case 0, 1, 2, and 3 from the action? So action is basically a number that you float into integer.
yes,
But I don't know,
exactly.
I do not understand how it decides based on that to go left, right, up, like, back and forth.
Okay,
The
so
conversion from that floor into 4 directions is the question, actually.
yeah, let me explain that, and also make sure that you have the vector, the position, like the distance calculate, like I mean the code, like the way I have it. Also, like you need, like the distance has, when the distance is less, like the final distance. So maybe you have that inverted. So probably that's why the thing runs.
Yes, I'm pretty sure I inverted that one.
I tried flipping this, and it still does the same thing. I don't know. Maybe I'll just try it again. I guess.
Maybe one thing, you should give less steps also. So that's, I mean, again, this is like a trial and error. So maybe here, maybe you give like 200 steps, and you increase, for example, like the step move. So we will discuss about this. So now, so in order to finish this session, the only thing that we're doing, we're just saying that the amount of possible actions that you have are 4. You can only do 4. And here we are specifying what each of the actions is. So this is move X positive, X negative, C positive, and C negative. So basically, because as like most of like machine learning like models and stuff like that, you start with random. This will start trying. Oh, if I try 0, basically the first episodes, it will just try to do something. Oh, action 0, it moves positive, X positive. So then it gets the feedback, right? If the Q value was like right or wrong and things like that. So then it says like, oh, maybe I should try now 2. Was it good? Oh, it was good. Maybe I should try more 2, then 2, 3. And that's the way it's learning. So the agent doesn't know anything. So that's the way you're mapping directly a number that at the beginning is random to a specific action. In this case, the moving forward, moving backward, right
So
or left.
can I simplify it in this way, that saying that each of those 4 cases are basically equal to pushing one of the buttons in your joystick, like 1 is left, 2 is like right, and something like that one.
Yes,
and
exactly.
then that maximum steps that you mentioned that we should reduce is actually the number of steps it should try and give up. So we are not going to have an infinite loop of like 1,000 steps. That's not going, like 1 million of steps that's already going away from the target. I applied the 2 comments that you made, like the inverting the that function, the 2 vectors, and I also reduced the number, and right now it is working.
Okay, good. So one final thing, so you try. So for example, you're not limited by 4 cases. It's good the analogy that you made with the joystick. So we can add, for example, a 5th case. And so this could be, for example, move also diagonal. So you can say that you move in positive step move. So you also add the step move so you can move diagonal, right? So in this case, we have 5 actions. So you need to go to Unity and try by ML agent. Here, instead of having branch 0 size 4, you add 5, and you have another type of movement, right? So that's the idea. So now you will have like 0, 1, 2, 3, 4, and it will learn how to map those numbers to those actions.
So when I change the branch size to 2, let's say 2 by 2, how does that affect the training outcome?
It doesn't affect like anything. So the only thing that you need to do is I mean, it will affect because I mean the structure is like more complex in terms of the other one would be like action 1. You will receive it from action from vector action 0 and action 1. So you need to just like modify the structure. So you use it here.
Ah, I see. Okay.
Yeah, that's it. I mean, we will have more complicated cases tomorrow, but for now, I think this is enough for you to think about this. And I hope it was clear enough as an example and also my explanation. And again, it's good that I finally have all my gear to explain you properly with Windows. Not that I don't like Mac, I love Mac, I work with Mac, but in a more fluid way, how to work with this. So I'll see you tomorrow again. Thank you for the attendance. I hope you like it, enjoy it, and I hope you learned something. I don't know. Let me know if you're not. So let me stop sharing my screen.
Thank you, Diego.
Yeah.
Thank you.
Thank you, Diego.
Yeah.
Thanks.
Okay.
Thanks.
Okay.
Bye-bye.
Thank you.
Bye-bye.
Bye.